Yesterday we talked about architecture as it was yesterday. Today we're going to talk about architecture as it is going to be in the future. And so I want to congratulate you for taking a look at what, these other speakers have talked about building systems and whatever, but at the heart of everything is an understanding of architecture. If you don't have architecture, you're not going to be successful. So let's start with all of the data in the corporation. When you take a look at data in the corporation, what do you find? What you find is structured data, textual data, and analog IoT data. The types of data that we find in the corporation, in fact, are very different from each other. It's kind of like the Antarctica, Sahara Desert, and Amazon jungle. These are all parts of the earth, but they are very different from each other. It's like talking about Sweden and Mexico. They are very two different places from each other. So let's now talk about the different types of data. The types of data that most people are familiar with is structured data. In structured data, we have keys, attributes, indexes, records, and things like that. And structured data comes from bank transactions, point of sale, telephone calls, payments, etc., and so forth. It's called structured data because the structure of each record is the same. Now the contents are different, but the structure is the same. Now let's go to textual data. Most people have not done much with textual data, but it turns out that textual data has got a lot of value. We have things like medical records, contracts, the internet, call centers, and things like that that all contain textual data. And why is it that textual data is so difficult? Well, there's a lot of reasons for the difficulty. One reason is because we have different languages. We don't just have English, although it's a good language to have. We have Spanish, Portuguese, French, Mandarin, Korean, German, and many other languages. Another reason it's difficult is because we have formal language, slang, and acronyms, and all of those have to be accounted for. Yet another reason why text is so difficult is that it comes in many formats. It can be written, it can be spoken, it can be on the internet, it can be on a video, and so all of these reasons make textual data, as important as it is, difficult to work with. There is technology out there to take textual data and turn it into a form that can be analyzed, and that technology is called textual ETL. The third kind of data that we have is analog IoT data. This is machine-generated data. I don't know if you know it, but all around us, every day, we have machines generating information. Your watches, your cars, your machines that you have in your manufacturing environments, all of them are creating information to be generated, and it's a different kind of information. In order to understand machine-generated information, I want you to think like a surveillance camera. And so suppose you have a surveillance camera on a parking lot of your organization. What does the surveillance camera see? The surveillance camera sees at nighttime not much. It just sees an empty parking lot. At 8 o'clock in the morning, it sees people arriving in their cars. At 5 o'clock in the evening, it sees people departing. And it's very normal, not terribly useful data that a surveillance camera sees. However, every now and then it sees something that's truly useful, such as somebody breaking into a car, or somebody having a car accident. Those instances are very important in terms of the business of the surveillance camera. And yet, from a standpoint of the majority of the data, the vast majority of the data in an analog environment is not of terribly great use. Some of the data is of great use and importance. And so that's the characteristic that we find when we look at machine-generated data. Now, a while back, an organization, I'm not exactly sure who, told us we need to build something called a data lake. And they said what we do is we throw all of this information into the data lake, and from the data lake we can do analytical processing. And what we found is very quickly the data lake turned into a swamp or a sewer, that nobody could do anything with the data in the data lake environment. And so our organization has spent a lot of money and a lot of effort and energy, resources, in terms of building these things called data lakes. And they woke up to find out that a data lake was not helping the organization, and it was something that was a liability, not an asset. So what we need to do is turn our data lake into something called a data lakehouse. Now, there's two things that need to be done to build a data lakehouse. Number one, we need to build something called an analytical infrastructure, which we're going to explain. And number two, as we load the data into the data lake or lakehouse, we need to make sure it's integrated, transformed, and vetted and cleaned. If we don't make these changes, if we simply take data and throw it over into our data lake, we end up with a big, expensive mess on our hands. And so what we need to do then is to transform the data lake into a data lake house. Now, who is this going to benefit? Well, the world talks a lot about data scientists, and I've known and talked with a lot of data scientists in my life, and I get this conversation when I talk to a data scientist. They say, Bill, I went to school, I learned all kinds of algorithms, I learned about statistics, I learned all of this stuff, and when I went into the real world, I didn't use any of it. I said 95% of the time, I was not a data scientist, I was a data garbage man, because the data that they fed to me when I was in the university was nice, clean, proper data, but when I got out into the real world, it was data that I couldn't do anything with. So I spent all of my time cleaning and messing with the data, and none of my time being a data scientist. And I can't tell you how many times I've heard that from the community. So what do we need to turn our data scientist into a productive person? Among other things, we need this thing called the analytical infrastructure. Now, in order to understand the analytical infrastructure, I want you to think about going to your public library. How do you find a book in your public library? How do you do it? You don't go and start to going to the library and going through the stacks and stacks of books. Because if you do that, you are going to be there a long time, and you probably won't ever find the book you're looking for. Instead, you go to a card catalog. And when you go to the card catalog, you look through the card catalog very efficiently, and the card catalog tells you where in the library to go look for what information it is you're looking for. And so that's the purpose of the analytical infrastructure. It becomes the card catalog that our data scientists and other people, analytics people, use to find information in the data lakehouse. So that's the first piece of infrastructure that we need. Now, you've probably never heard of an analytical infrastructure before in your life. So let me talk a little bit about what we call the analytical infrastructure. The analytical infrastructure is nothing but metadata. It's metadata that tells us about information in the data lake. But it's not just normal metadata, because you see, people that have operated in a structured environment all their life think of metadata as such things as a data model, DDL, and things like that. And those are forms of metadata. But because we have different kinds of data in our data lake, we need some different kinds of metadata that you probably never heard of. We need some things called taxonomies. We need things called ontologies. We need, when we go over to analog information, we need something called distillation algorithms and inline contextualization. So when we talk about this analytical infrastructure that we need to turn our data lake into something useful, it turns out that the analytical infrastructure itself is a large, complex structure. That's because we have different kinds of data in our data lake. So that's what we need to take the data scientist and turn the data scientist into somebody that's useful. The second thing we need to do is we need to take care in loading data into the data lake. We don't normally want to just load raw data into our data lake. Instead, we need to take our data, our raw data, and cleanse it so that it's useful for analytical processing. And how do we do that? Well, when it comes to structured transaction-based data, we typically use something called ETL. And ETL's been around a long time. The second thing that we need to do is when it comes to text, we need to use this thing called textual ETL. We need to take the raw text, go into the raw text, find out what's useful, organize it, and put it into the data lake. The third thing that we need to do is to distill the analog data. Now, what do we mean by distilling the analog data? What we mean is we need to separate the useful analog data from the unuseful analog data. And we do that by reading the analog data and determining which part of that analog data is going to be useful. I'd like to talk just for a second about how do the police do that today. You see, the police have these large amounts of videotapes looking at something, and they're going to go look for a robbery, for example. How do they do it? Well, somebody sits down and has to watch hour after hour after hour of videotape. And finally, one day, they discover, oh my gosh, this 30 seconds worth is where the information is. That's the hard way to distill information. And you can do it manually, and you can do it that way, but that is the hard way to do it. But that's what we mean by distillation of analog data. Okay, computer. Now my computer has decided to go to sleep on me. There we go. Okay. So one of the processes you have to go through is textual ETL. You've probably never heard of textual ETL before, but textual ETL takes things called taxonomies and ontologies and inline contextual specifications, takes that input, takes the raw text, and turns it into a standard database format. And we can use this for things on medical records, call center information, internet information, and so forth. The machine-generated data, the distillation process has the effect of taking the high probability useful data and putting it one place, and taking the data that isn't useful and putting it somewhere else, typically in something called bulk storage. And so again, here we see, in the case of a surveillance camera, A robbery occurred at 6:31 a.m. on a Tuesday, and we have 3.5 minutes worth of video for it. An accident occurred at 5:15 p.m. on a Thursday, and we have 1 minute worth of tape, and the rest of the information on our surveillance camera is not of particularly great use. Now, as a data architect, there's some things you need to think about. The first thing you need to think about is volumes of data. You see, the volumes of data that we're talking about are not equal. That in structured data, we have a certain amount of data. We go to textual data, and there typically is a lot more textual data than structured data. Then we go to analog data, and there's a lot more analog data than there is textual data. So the types of data that we have are not equal, and we have to accommodate that in our architecture. And how do we make that accommodation? Well, we take each of our environments and look and find where there is business value. You see, in the structured world, there's a lot of business value. In the textual world, there's some business value, and in the analog world, there's very little business value. And what we do is we take the data that has great business value, put it over into our data lake. We take the data that doesn't have business value and put it into bulk storage. So there's really 3 places where data can go once it enters into the system. You can throw it away in the trash can if you want, but you can never bring it back if you do that. You can put it into bulk storage, where at a later point in time, if you have to, you can bring it back. And the third place is you can put it into your data lake. So this is how analog data is divided. Now, just because you put data in bulk storage doesn't mean that at a later point in time you can't go back and get it if you want to. It's usually a complex, time-consuming operation to operate in bulk storage, but it can be done. You can go back to your bulk storage environment, scan it, and find data that needs to go into your data lakehouse. By the same token, you can take data from the data lakehouse environment and archive it into bulk storage. So I'm describing to you the architecture of data, of how to manage large amounts of data in a corporation. And who benefits from this? The people that have to do analysis benefit from this. Certainly, your data scientist developer is somebody that benefits. Why do they benefit? Because they can find data, and because when they find the data, they can believe the data. It's accessible to them, it is believable, it is able to be found, and able to be combined with other data. That's what happens when you convert a data lake into a data lakehouse. The analytical infrastructure, is it something that's easy to build? I would be lying to you if I told you that the analytical infrastructure is easy to build. It's something that's an ongoing project. It's something that you're going to start today, and perhaps 10 years into your career, you might finish. But it's not something that you do overnight or quickly. And so that's building the data lakehouse is an ongoing project. It's not something that you do once and are done with it. Now, one of the questions I get asked about this time is a data warehouse the same thing as a data lakehouse? And let me try to give you the best answer that I can give you. The best answer is, suppose we had 2 cousins sitting in the same room, a young man and a young woman. And when we look at them, their facial structure is the same, their color of their hair is the same, the color of their skin is the same, the body type is the same, and it's clear that these 2 individuals are definitely related. On the other hand, if we were to look at the DNA of these two individuals, we'd find that the DNA is different. For one thing, one is a female and the other one is a male. So there is a difference in the DNA, but they're nevertheless very similar to each other. So once we build the data lakehouse, we now have an analytical infrastructure on which you can build upon and improve the lives and livelihood of many people. By the way, one of the questions I get asked when I do this presentation is, Bill, who invented the terms data lake and data lakehouse? Well, I know the people that developed data lakehouse was a company called Databricks. I'm not sure who developed the term data lake, but somebody asked me, gee, Bill, did you develop data lake and data lakehouse terms? And I did not. And I know it's confusing. Data lake sounds like a data lakehouse, but indeed they are very different. Now, I have some information for you, and the good news is the information I'm about to give you is for free. If you're interested in a free book on how to do all of this, there is a book you can get on the internet called Text Analytics Simplified. You can simply go to the website there, tell us where to email the book, and it will be at your doorstep in a short amount of time. In addition to which, we have a prototypical data architecture. And the prototypical data architecture looks like this. What you can do with this prototypical data, and this is free, by the way, we don't charge anything for this. You can take this data architecture and compare it to your data architecture to see where the differences are. And in doing so, you can find out how you might have a difference between your data architecture and our data architecture, and it might help you to look into the future to see what is ahead of you. And again, you go to the website that I mentioned, and you can get this architecture for free. And then finally, there are books that are out there. If you're interested in reading the books, you can get them on Amazon.com. There's a book on data lakehouse architecture. There's a more detailed book on the data lakehouse. And then finally, there is a book coming out after the first of the year on a methodology for building a data lakehouse. So that is a little conversation about the data lakehouse. We've talked about what is a data lakehouse, how do we build a data lakehouse, why do we need a data lakehouse, how it's different from the data lake, how it helps our data scientist and analytical environment. That's a little conversation today about the data lakehouse. We probably have a few minutes here, and I'm available for questions if anybody has questions. Yeah. No questions. Yes.
How did you start your collaboration with Databricks? What attracted you from them, and how did this start, this friendship with Databricks?
Databricks called me on the phone about, a year and a half ago, and they were looking. Databricks had this idea about a data lakehouse, but they needed thought leadership. And because of the work that I've done in the past in data warehouse, they said, how would you like to provide us a roadmap for what a data lakehouse is? And so I don't work for Databricks. They're good people, and I like them a lot, but I'm an independent consultant and a thought leader. But indeed, Databricks did call me and ask me to help them give a definition to a data lakehouse. Okay. Any more questions? Well, we can talk about the local soccer team or the local hockey team or football. I mean, you probably don't watch American football, but we can talk about American football. So if there are no more questions, then I guess yes, sir. I need to get closer so I can hear you better.
We're seeing the AI revolution, or what we want to call it, with large language models grabbing all types of relevant data and asking or answering the questions of users. Where do you see the Lakehouse in that system setup?
Okay, I'm going to tell you some words you're probably not going to like. But I want to warn you before I tell you these words that you're probably not going to feel comfortable with them. I want you to imagine technology, AI, machine learning, data mesh, all kinds of technology. And underneath the technology is data. What happens when you have the world's best AI and you have bad data beneath it? What happens? You get bad results. And one of the things that I blame the AI developers for is they don't recognize that they're standing on a foundation. They think we're just going to go make some wonderful things over here. But if the foundation that they're operating on is not a sound foundation, I don't care how smart and how clever and how beautiful or whatever they are like that, they're not going to come up with good results. And so what we're talking about here is making the foundation on which AI and machine learning and data mesh and all of those things that are interesting developments going to operate. But again, they all operate on the assumption that we have data. Well, guess what? In most corporations, we don't have data. We don't have data that we can use. And so the data lakehouse sets the stage for successful AI. But the people in AI don't want to hear that. They say, oh, these are just a bunch of old guys over here, and you know, so I hope that explained it. But and you know, I get asked that question. Gee, ChatGPT. What if you write a book that says the moon is made of cheese, and ChatGPT comes along and reads the book? What's ChatGPT going to tell you? It's going to tell you that the moon is made from cheese. Well, I've never been on the moon, but I have good reason to believe that the moon is not made of cheese. But ChatGPT will tell you that with a straight face. So there's this foundation of data that we operate from. And what we've talked about today, the data lakehouse, is that foundation of data. Yeah, you're welcome. And I get asked this question all the time. So, because people say, oh, AI, everything. And there's nothing wrong with AI. AI is great. But only if it operates on a foundation of proper data. If it doesn't operate on a foundation of proper data, AI is misleading and will give you bad information. Okay, thank you for that question. Any more questions? Now, all the questions have been asked by this side of the room over here. We need to have this side of the room ask a question over here. Yeah. I need to come over so I can hear you. This is a sign of being old. By the way, I came to this conference, and I'm going to tell you something. I'm the oldest person at this conference by 20 years, but I need to hear you. Yes?
I'm wondering if there is any technology that is coming soon for the data.
Data Lakehouse?
Yeah, as the data lakehouse or the data.
Well, there's a couple of things that are out there. There is a methodology for building a data lakehouse that's coming out as a book right after the first of the year. And then there's this thing called textual ETL that allows you to take raw text and put it into a form that can be used. So there are those two technologies. If I were looking to make a lot of money, I'm too old to think about money, but if I were to be thinking about making money, building distillation software, being able to go into that analog data and separate the analog data according to its usefulness, somebody is going to make a lot of money being able to do that. Because it's not done well today. Think about the policeman. How do the policemen take 3 days worth of videotape and analyze it? They sit there and they look at it. And the poor person that has to do that, their eyeballs start to bleed. They say, oh my God, I got to look at 3 more hours of this. And then finally, in 30 seconds, aha, here's what I'm looking for. But it took me 3 days to find that. That is a crude way to go. There has to be a better way. Okay, any more questions? Yes.
So I'm a bit new to this, and it's really been exciting to hear your talks and also the journey from data warehouse and data marts you talked yesterday. I was in a talk yesterday talking about knowledge graphs. I was just curious to hear your point of knowledge graphs and if this fits into this.
Stay tuned for an announcement because yes, they are now currently, as we speak, making a connection between the raw text and knowledge graphs. And very shortly, as shortly as in the next month, you're going to be able to take text in its raw form and assimilate it and then put it into a knowledge graph, which is going to be very useful. And that's going to be done with a company called Neo4j. And
that's the guy I heard from yesterday. So,
yeah, well, right now, the connection between text and knowledge graphs is being made. And it's still early to announce anything, but very shortly, as in the next few weeks, there should be an announcement forthcoming. Because knowledge, the way I look at it, let's take a look at dashboards. Dashboards like Tableau and Click and things like that, they're useful things, but they make the assumption that the relationships of data are static. And in fact, there are some relationships of data that are static. Nothing wrong with that. The problem is there's a lot of relations of data that are not static. And that's where knowledge graphs come in because they can understand and interpret those dynamic relationships that can't be done with a dashboard. So I look at knowledge graphs as being an extension of the analytical technology that we have. Okay, any more questions? Yes. Okay, can we do what?
Who's winning on Sunday? The Seahawks. Football question.
Yes.
Who's winning on Sunday?
Who's winning on Sunday? Well, the Dallas Cowboys are playing, so who they're playing? I think they're playing Cincinnati. And I hope Dallas wins there. Kansas City is playing the Chargers, and I think Kansas City always wins. And Miami is coming back from a loss, and Miami's got a very good team, and they're going to win. So Miami, Kansas City, and the Dallas Cowboys are who to bet on. And when you bet on them and make a lot of money, send me some of the money, okay? Okay. Any more questions? Yes.
Since we're off to football, I dare to ask the question, what's up with your Windows 7 computer and the activation code in your presentations?
I have no idea.
So it's just an old laptop with Windows 7 that has been updated over.
When I bought that laptop, it was new. And, and it's like my best friend, and it goes with me everywhere, and I love it, and it works. And so now, just because we have a hard time hooking it up, I'm sorry about that, but it works. And that's all I want from a computer, it working, you know. I don't care about the operating system. I don't care about the database. I don't care about it. I just want it to work. So, thank you.